So till that, you have any queries on understanding the creation of threads and then a basic idea between thread and process and the other properties of the threads? Like any questions so far? Okay, so yesterday we were like discussing about the term context switching, right? So the context switching is like basically you're switching your processes from one state to another state. And whenever you're trying to switch this process, you might be ended up with an interruption because that process might be working for some other program. And when you're trying to give one more additional program, there might be an interruption happening between these two processes because earlier the state of the process was new and right now it was running, and the process which is getting assigned or which is like who's assigning the task to that particular process may not know the state of that particular process, and that can end with an interruption. So there might be chances for us to handle those interruption exceptions when we work on the multi-threaded platform. So this context switching is basically happens when we are trying to do multitasking. So for example, like if yesterday we created one thread object. So if you wanted to handle more than one threads and for each thread you want to give separate programming task or some kind of function to happen, in that case, when there is a relation between these two, say for example, one of the thread is responsible for doing the debit activities, and another thread is responsible for doing the credit activities. But if your data is not updated, these two can get into an interruption, or if they are both are doing happening in a parallel way, they might also end up with an interruption. So we are going to handle that in a more efficient way using thread related keywords called synchronized, volatile, and transient, which we'll see today. And with that, how can we avoid this interruption? So basically the context switching is like you're switching the control from one thread or from one process to another process. And this basically happens even in your operating system. If you want to switch from kernel mode to a user mode in your Linux or in the Unix, there also this happens. So the switching is like basically switching the state, like whether it is static or it is like dynamically working, or you wanted to suspend that particular thread. That is falls into the context switching part. And if you can go into deeper with related to operating system, but in terms of Java, this would be the basic idea of the context switching. So we'll see how we can reproduce the interruption exception and how to fix that. Let me share my screen. Yeah. So yesterday we saw about the illegal state exception. So whenever you're trying to start a same thread again, you might end up with an illegal state exception. So we'll see how the interruption exception can be taken care of. So let's say now you already have a thread. Let me go to this one where we have the extend thread. And here I have a void method, and let me use this run method and write a logic within it. Just I'm going to use a for loop. So there is something called sleep. So what does this sleep does? Let me tell that as well. So since this is a an exception block. Let me handle it. Let me just print the, I'm just doing iteration, nothing else. Let me print the, so now instead of creating one thread, I'm going to create multiple threads. So if you see right now, the execution was parallelly happening. So how many threads I call, the iteration was similar. So 1, 1, 1, 2. So this may not be same every time. If I execute right now again, you see here, the thread name is different, thread 0, and this is another thread with thread 1, and both are in the running state, and that value is getting printed every time. So if I call, instead of thread.start, if I call directly the run method, you see the execution, this is different. This time, the first thread, when I call the run method, this was like a normal method. You have a run method in your class and you're just calling that run method. So the complete execution of that is completed. And then the second control has been taken care. And then you have the execution of the second run method. It has been initiated from your second object. But earlier, whenever you started the thread start, it was a parallel execution. Like both things happened together. Did you notice the difference in both the outputs? So did you observe? It's actually happening parallelly. Whereas if you're just calling the run method, it's like complete normal Java object and method calling. And once this entire flow is completed, you will be calling the second run method from your different object. So this is the difference between your thread as well as the normal object. So the same thing you can do from your normal Java class. You can create one more instance and you can call the run method directly. It will be like a normal method. But in case of thread, what happens? You're doing a parallel execution. So parallelly, your data is getting executed. So when this kind of execution happens, and if you're trying to do some kind of upgrade thing or kind of any kind of creation or deletion in that particular flow, you might end up with an interruption exceptions. So till this, you have any queries in this part? Kiruba or Janaki, you have any queries?
Oh, no, thank you.
Okay, so why this, but what has actually the sleep method does? So we need to understand that. So this sleep method is like to avoid that particular kind of interruption. What we are trying to do is we are giving a wait time. Okay, once the thread 0 is being started, you're telling that you go and execute it, and you take a 500 milliseconds of time as a break time, and by the time the other threads keeps running. What if I now reduce this? I just comment it and let me run it again. See, this was like a 2 separate threads again. So it's like a normal program execution. So there was no, there's no difference between normal Java object calling and the thread object calling. It was a normal thing. So when I gave the sleep time, what happened? My initial thread was in resting mode. So the other thread, which was parallelly executing, got a chance, and it was executing the first level. And by the time it got completed, the second value was being, the second loop iteration was taken care. And this was happening parallelly. So this sleep method will help us to avoid these kind of things. But this is basically like to give a pause time between the threads so that they won't get into a deadlock situation. So we'll see how this deadlock can be resolved a little late. But right now, the sleep method is something where you're trying to give a wait time for your thread object to just wait till the time you have mentioned and then progress accordingly. So that is the purpose of sleep. And this is again an overloaded method. So you can see the sleep with a long, and the other one is long with milliseconds and the nanoseconds. So this actually makes you a thread to wait for some time to avoid your interruptions. So there is also a method called join. In thread. There's a method called join. If you see, this is again a final method. Why? What is the difference between the sleep and then join? So this actually like it will stop the particular thread to execution. So whereas in the earlier sleep mode, we were giving something like a pause. It's not completely stopped, right? Whereas in join, you are completely making that particular thread to stop its execution, and then it will complete the task post that. So it's similar to sleep, but main thing is like your the entire execution of a thread will be stopped. So we'll see how that actually works. So here we have already created 2 instances of thread object. So let me say phr.join. If you see this time, the output execution of your thread. So the first time I made a call to my thread, only the first thread, and the thread was completely done. And I just gave thread.join. So it was suspended, and then it was a parallel execution happened because both the threads are running together. So if you see, this is the one. So let's say, so it completes the task 1. Since you have given join for first thread, it completes your first thread completely, and post that it goes and completes the other threads. If I haven't given this one, my output would be like 1111, 2222, 3333. since I gave join, it was like making the other threads to wait. So the first task is my thread 1. And once that is completed, I'll be progressing for the next threads to start on. So it's like a scheduler where you're giving the opportunity for the first thread. And unless that is getting completed, you're not going for the second or third threads. So this would be the difference between the join and then without join. So if you're not giving join, what happens? It's like a common level of priority for 3 threads. So it will be like parallel execution. But in your case, if you want to prioritize any one thread and you have to give load to that thread, and that has to be the like it should be the completed task. So in case of bank debit and credit, you have to make sure that your data is proper every time post your transaction. So what we can do is for that particular thread, whenever a debit is happening, immediately the DB has to be updated with the latest value. That should be the thread. Only then the second thread and the third thread can come in and do the other operations of credit or any other activities. So this is the purpose of join. And this is again an overloaded method. So which accepts again similar to your sleep with a long value. And there's again a method with long as well as the int method. So did you get an idea about the sleep and then join? What is the difference between these two? So sleep actually pauses your control on the threads, but it's a parallel execution, but it pauses. Whereas in join, it is like prioritizing the thread where you apply your join. So unless that task is completed, rest of the threads will not initiate the work. So
one question.
Yeah.
So what if you give this join after starting all the 3 threads?
For all the 3 threads after starting?
Yeah.
Let me do that.
No, let's try with join only for the first thread.
Okay.
The other two threads should be waiting, right?
But you have already started your thread, right? So what is happening is, let's explore that. So what happens is, unless you make a control on your thread immediately, that will not happen. We'll see what this time it happens. See, it's a normal execution. Your thread join didn't take care of because you have given it post completion of or initiating of your tasks, right? So this is like, okay, you have already triggered my control, and later if you give join, it won't work. So this is something you have to give prior.
Okay. Okay.
Okay. So any other questions you have?
So here, like you created 3 threads, right? Like previously you used the join after the first thread. So that means like once the first thread completes, only the remaining 2 will get triggered, right? That's the purpose of join, right? It will stop.
Yeah, so the join is like you're stopping the execution of other threads unless the control where your thread has that completes your task, you're stopping the control over the other threads.
Okay, got it. Thanks.
So it's like first come, first serve. Like whoever comes first on the thread, and if you have applied join, unless that person's work is done, you'll not allow the other person in. That was the join this.
Okay.
Whereas a sleep is like you'll allow one person and same time you'll allow another person. It is a conversation between 2 in the same room. So one question to the one and another question to the other one. So it's like a parallel thing happening. But you have a wait time. Okay, when the first question has been asked to the first person, the second person has to wait by the time. And when the second person answers, the first person has to wait. So there you'll have that waiting logic. Whereas in your join, it will be like a complete wait for the other threads if you have triggered join to any of your thread part. So they can't get in unless you allow them. Okay, so whenever we execute this, if you want to get the current thread name, like so far we were using the get name. So there's something called as current thread, okay? Which is again a static method. So you see this time, the current thread name is main. It was not thread hyphen 0 thread hyphen 1. So every time the current thread which is getting executed is your main thread. And within that, you have your thread names created for each of your thread object, which you have created with start method. Okay, so that is the reason you're able to see the current thread as main. And apart from that, if you wanted to see the naming convention of your own thread, which you have created, you can have your.
Or if you print this thread dot current thread dot get name in run method, it will work, right? If you print there.
Yeah, it will print there whenever you're starting that thread object is getting passed, right? So you can do there also.
So along with the number, if you give.
Wait, here.
And we print the number. Yeah.
You can see like here itself, the ordering is not in a sequential format. It's like any thread can come in and work on. So the only thing is like the first thread you got output, but that was part of thread 2. And second time you got thread 1 and this is thread 0. And this is not like repetitive. So if you see the first time it's 102, next 102. Sorry, I'm missing it up. 210, 210, 210, 210. So this order will not be static every time. So whenever you execute it, the ordering, so this thread name happened a little later, but you see now this is happening immediately. So you never knew how in the backend the threads work. You can just predict, okay, this is the way it works and we are going to have this output, but you can't be very accurate on the sequential flow or a parallel flow or which thread first gets executed in the entire sequence. That you might not know. So if I just replace this over above here, and run it again. You see this time the first importance was given through a thread 0 and post that the rest of the threads were taken care parallelly. Okay, so did you get an idea about the current thread? So if whenever you work on multiple threads and you wanted to understand like which thread is actually getting into picture, and in that case you can use this current thread to print and understand like how the flow is actually happening in the backend. And along with that, you can also have your thread names. That I try to print here. So you can see the thread ID. Oh, sorry. So you can see the thread ID, which is getting a different value every time. So this is like 12 and 13, which is like backend in the JVM architecture. It will be automatically allocated with some random ID, which would be a long type data type and not an int data type. So if you wanted to very much depend on your thread IDs to understand the flow or thread name, you can use this also one of the attribute to consider. Yeah. So coming back to thread priorities, as I said earlier, we have 3 priorities. One is normal, the other one is minimum priority, and the third one is max priority. So you can see a max priority with 10, a min priority with 1, and a normal priority with 5. So based on these priorities, you can actually execute the flow of the threads. If you don't want join method or sleep method, but you wanted to prioritize based on these levels, then you can use the priority as the key for your thread execution. So as I said yesterday, there's something called daemon thread, which will be like in the back end. It's actually the main thread which provides you the entire service, okay, for even for the user threads which you create as part of THR1, THR2, and all these things, right? So this is basically like a service provider for your entire thread perspective. So how can we evaluate that? So let me give a small condition here. So since I can get the current thread name, I use the current thread, and there's something called is daemon thread or not. So if this is a daemon thread, I'll just print out otherwise it should be a user thread. So what I'm going to do is I'm going to create a daemon object. So since I have the thread already object created, so I'll create one more thread object, thread extend, which R3 equal to new thread extend, which R3 dot start. And I'm going to set this thread as Boolean true. So only then I'll know whether that falls into the daemon thread or not, right? So for our understanding to practical purpose, what I'll do is thr3 dot set daemon, and I'm going to give a flag as true.
What if we call this run directly from main?
Yeah, so if you call the run method, it is like a normal method in your Java class. So it's like, it is not like a separate call stack will not be created. So I explained this yesterday. So what happens is, let me open the paint. So you know how a stack structure looks like.
Yeah. Listen to yesterday's class. So
yeah, okay, fine. Yeah, sure. So what happens is, whenever you create an object, so first you'll create an object T1. So T1 is your first instance, and you're calling dot run directly and not the start method. Okay. So what happens, your T1 main method is already available. And on top of that, the run method, which is the second method on your class, will be again added into the same stack. Okay. So this is not in a separate stack. It's like a single thread. Main is already a separate thread. And on top of that, you're using the run method as a normal Java method, and there is no separate call stack getting created. But in case of, if you call start method, okay, so what happens, your main method would be here, which would be running in the main thread, and there'll be separate call stack created, and where you have your T1's run method or start method. Actually, basically, you can find that difference easily. So let me say, so since
I thought
the state,
since you said,
I'm giving the state.
No, I thought since you said main method is taken care of by one daemon thread. So if we call run from main directly, I thought it will print.
So the main would be like main actually would be taken care by your JVM. So you don't need to how to say, think about it. But internally, if you just call this run method, it's like a normal Java method. It's like it won't think of an overridden method or something. Because you're calling it directly run. Okay. So right now I'm just gonna call start and see the state of each thread. Okay. So if you see the state, it is runnable, runnable, and runnable. Okay. Now, if I call run method instead of start, and let me execute again. You see the thread state, it is right now in new, right? So it's again in new state. In that case, what your thread is not actually created. You're just an object is being created as part of your thread class, as part of your Java class, and you haven't used your thread itself. So it is like a normal Java run method getting called. So what happened? Your thread is not getting created. So it's still in the new state. So you can reuse anytime only when you trigger this start. If you're just calling the run method, it is like a normal Java program where you have a method and you're invoking through an object. That is the only difference. So only if when you use as a thread object to kickstart, only when you kickstart, it will be considered as a separate thread. So all the properties of your thread, like your code, data, register, stack, entire thing would be in separate. So they won't be like overloaded on a single stack. It will be like separate threads, separate processes. So everything would be on a separate thread and you can handle them independently. So if you do that, so everything is happening from a single call. So your order of execution, if you see that, it would be like a different one every time. So it's a user, next the second thread started, the complete second thread completed, next a third thread. So it will make a sequential flow. Only if you use this thread start, your output would be in a parallel execution. So for the first one, since I have given join, the first 4 got executed. And if you see here, both are runnable. And then if you see this is getting executed parallelly. Okay, I don't know, I didn't comment this one. So if you see, these two are happening parallelly. So this parallel execution you will miss if you just use run method directly. Only if you use start method, like it will be like 2 separate processes working together. So that is the reason we need to call only the start. It's like your bike where you kickstart only once, and once you kickstart, you'll just drive and go, right? But if you want to use run method, every time you have to make us put your bike in a stand, and then you have to kickstart again and again, and then you have to make. If it's like automatic kickstart, it's like just one time activity. So for the one-time activity, we always use the start method where you'll have it as a complete separate process. If you use run method, you have to do it manually on top of the normal Java program. Did you got it?
Yeah, I got it.
Okay, fine. So now we have set this set daemon, and so if you see here, the entire flow, you can see the priority was given to the user threads. So thread 0 got the user thread, and later also your execution, if you see the pre-order of your execution of thread 1, thread 2, and you can see this as a daemon. All your execution of daemon is happening on the last part. Why so? Because the daemon has a least priority in execution, because that is taken care by your JVM internally. So though you set your thread as JVM or set your daemon value as true, the JVM will consider give its priority as lower one, and the other threads which are in the user threads, right, which has more higher priority, would be considered first. So the lifespan, what I can say in a simple thing is, the lifespan of a daemon thread is directly proportional to the user threads which you have created. So whenever you create your own threads, you can have the control to terminate them or dismantle them. But in case of daemon thread, it will be like always available in your JVM. So that is the reason the lifespan of daemon thread will be like in the lower priority, and it will be available anytime. Whereas in the user threads, they may die if you wanted to end that particular thread process. But in case of daemon thread, you can't do that. So if you want such kind of activity in your user threads as well, we can use this set daemon and make it true. Though it will have least priority, these threads will not die. So it will be like a continuous threads running in the background. Like you have your background tasks, right? Where every time you launch a program or something, in the background you'll have your, if you even open the STS editor, you can see this one. Like here, the number of applications which are running or the number of jars which are getting loaded, everything would be happening in the background where you can just monitor some progress happening, but you not witness that. So that such kind of activities will be taken care from your daemon thread perspective.
So daemon thread will not get killed. It will be active, right? We need to
it will
manually...
be active with a lower priority. So that is what the main thread, right? You have your main method, which is active every time. But if you want to have your own user threads to act as daemon, then you need to set this particular Boolean flag. So that is a kind of feasibility they have given if you want to have the feasibility or to achieve those properties of the daemon thread in your user threads too.
Okay.
So yeah. So let's see how to do this multi task by your threads. Okay. So let's create one more thread. Did I use this anywhere? So whatever I'm trying right now is like from the extending thread class. You can do the same thing from your runnable also. But why did I prefer this extension is like I can just call the start method directly. Otherwise, if it's a runnable, I need to implement that interface and then call again a thread object, pass that runnable object, and then start. It's like one piece of line extra for each thing. So that is the reason I prefer the extended class method. If you wanted to try in runnable, you can still try the same piece in your runnable as well.
Okay. And at the end of the class, can you please share the code?
Yeah, I'll share this code. Sorry, I forgot. Earlier also you asked some piece of code, right? I'll just upload and share these things. So let me create a new class. multi1. Let's see if this all extends. Just have the run method. Two. Spread. This would be the main thread class where I'm gonna